Hello, class. Today we're in Chapter 1, Lesson 5, Raising to a Power. And in this lesson, we'll be dealing with exponents. And exponents are very important in algebra. They will pretty much carry all the way throughout your math lives. And when I say math lives, meaning in the future as you head into higher levels of math, such as geometry, algebra 2, trigonometry, calculus. So pay very close attention to this. And let's start here. We have a quote from Benjamin Franklin. It is an amusing speculation to look back and compute what numbers of men and women among the ancients clubbed or put together their endeavors to a production of a single modern. And what he's basically referring to is if we look back and we look at our ancestry and we look at uh, our genealogy, the generations back, and we'll read more here, how many people it actually took to make one person, which is you. So let's just take a quick look here. It says if you trace your family tree through 10 generations, how many ancestors would there be in the 10th generation back? Because you are descended from two parents, each of whom had two parents, each of whom had two parents, and so on, the numbers in each generation back are, well, we have here 2 parents, 2 times 2 grandparents, 2 times 2 times 2 great-grandparents, 2 times 2 times 2 times 2 great-great-grandparents, and then we have 2 times 5 times, that's 2 times 2 times 2 times 2 times 2, great 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 grandparents, and so on. It can be seen from this pattern that a person who has 2 times 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 2 ancestors in the 10th generation preceding his her or her own. A simpler way to write this number is 2 to the 10th power. So let's go ahead and put that up on the board. Okay, we have a 2, and then we have a little number up here representing the power of 10. That is the exponent. Okay, the 10 is called the exponent, indicates that 10 2's are to be multiplied. And if we go ahead and do our math, we will see that when we multiply 2 times 2 times 2, and we do that 10, multiplying 10 2's, we will have 1024. Okay? In the 10th generation back, you may have more than 1,000 ancestors. So this is what Benjamin Franklin was referring to, that if you take your generations going back, meaning you're just one, but you go back 10 generations, there were over 1,000 people involved just to bring you into this world. The solution, reading back on top of page 29, the solution of this problem requires repeated multiplication by the same number. Such an operation is called raising to a power. The number of grandparents that a person has is 2 squared, right? So we know that. We have 2 grandparents. Let's say you have mom and has 2 parents, so there's 2 there, and then your father has 2, so that would be 2 squared, or 2 times 2, which means you would have 4. So going back here, the number of a person's great grandparents would be 2 to the 3rd power. Okay, now let's go ahead. I want to illustrate what this is. 2 times 2, and we know that's equal to 4. So you have 4 great-grandparents, and so if we were to go back, we would have to multiply 2 times 2 times 2, and we know that we would have 8 great-grandparents because each of our grandparents had 2 parents, so it would be 2 times 4. Okay. In each of these cases, we can represent the number by geometric patterns of circles. Because 2 squared can be pictured as a square, it is also referred to as 2 squared. So if we're looking at our picture here, let's take a look. We would have a square like this, right? And that would be 2 squared. And that would be, well, if we look at this, we can say 2 times 2, right? We would do this if we were multiplying to find the area. Okay. And because 2 to the third power, or 2 cubed, can be pictured as a cube, it is also referred as 2 cubed. So we have another picture here, and I'm going to draw it similar to the one that we have. Well, I'm not going to run out of room, so I'm going to have to take a different angle. And you'll note that my drawing skills are not as good as maybe yours. But here we have a cube that is being represented in the back. Okay, so there's our little cube. And again, if we were to be doing the volume, we know that we would multiply the height, maybe the length, and the width. Let's see, put another 2 in here. So if we were looking, and this is called cubic volume. We're not going to go too deep into this. You'll probably deal a lot more with these type of things as you go further on in math. But these are terms that you should know: squared, and we have cubed. So those two we give particular names. Now, if you go 2 to the 4th power and 2 to the 5th power, we don't have specific dimensions for those. But you should know that 2 squared, or 2 to the 2nd power, is 2 squared, and 2 to the 3rd power is 2 cubed. Space, as we know, is limited to 3 dimensions, so powers higher than the 3rd do not have special names. It is important to understand the difference in meaning between multiplication and raising to a power, and in the symbols used to represent each of these operations. The following examples should make this difference clear. 3 times 4 we have here, okay, is 3 times 4, or 4 plus 4 plus 4, because it's 3 times. We're going to add 4 3 times. Now, when we say 4 cubed, we mean 4 to the 3rd power, or 4 times 4 times 4. So there's a big difference between 3 times 4 and 4 cubed. Okay? Now we can also say here that we have 3 times x. So I'm going to go back to the board here, and this is where in algebra we need to be very careful here. We have 3x, which is 3 times x, right? We could have written this, let's say 3, and we use our little dot, which we already learned how to do that. So we had 3x, or 3 times x. Well, we know that that's basically x plus x plus x, okay? So it's 3 times x. Now, much different than when we say x cubed, okay? See, 3x and x cubed are not the same, because what we're saying when we're raising to a power, we're saying x times x times x, which would be much different. If we go back and look at 2 cubed versus 3 times 2, we could have a different result, because 3 times 2 would be equal to 6, but 2 cubed would be 2 times 2 times 2, which is 8. So let's always be very careful. We understand what we're doing with our exponents. We have a couple more examples. We have n x, which means n times x. Anytime you see letters together, numbers with letters, and there are no signs, it means simply that they're being multiplied. Not until we put that n up into the little corner where we see x to the nth power, okay, then we're actually using an exponent. Okay, so just remember, this is how we will be writing. We'll be using these terms as we move along into our next lessons and chapters.